Hey guys, it's Mr. Katz. Just here's some problems to just help you practice. My advice is to pause the video and then watch me complete the answers. I'm going to do them right in a row to save time, but go ahead and pause the video after as you see each problem so that you can practice it on your own. Here you would distribute everything to the negative third power. You cannot solve negative 3 to the negative third because it's going to be a fraction. So we're going to leave it like that, power to a power and power to a power. So you get a 6 here. Now, anything with a negative exponent is going to go to the denominator. So we got to put a 1 up here, and everything actually goes. And it gets to be a positive exponent, but we leave it as, remember, the base is still negative 3. And then last, negative 3 to the third power is negative 3 times negative 3 times negative 3, which actually is a negative 27. I could put the negative sign out front because the whole fraction is going to be negative because you have a positive divided by a negative, negative 27. You could have put it by the 27 too if you really wanted to. And there's your answer. 1 over, negative 1 over 1/27th, and then x to the 6th, y to the 15th also in the denominator. Here's the next one. When you have a fraction that's squared, everything, including the numerator and denominator, gets squared. So 4 squared I can actually do. That's 16. A to the 4th. And then 25, b to the negative 4th. And the last step is going to be the negative exponent is going to flip back to the top. And 16 over 25 cannot be reduced. So there's your final answer. Next one is the multiplication of two monomials, but you first want to square this entire one. So negative 3 squared is actually a positive 9, a to the 4th y squared, times this. Multiply the numbers, and I can multiply anything with the same base. A to the 4th times a is a to the 5th. Y squared times y to the 5th is y to the 7th. I'm going to put the b times, there's nothing times b, so I'm going to leave it as b. Y to the 7th. And I put it in, that's 36, a to the 5th, b, y to the 7th. I put it in alphabetical order. It's okay if you switch the b and the y, or the a and the b. Next one. Here's a problem where you first want to distribute the negative 1/2, but the only thing in parentheses is the numerator. So everything in the numerator goes to the negative 2 power. And then, before I start flipping things, I actually can divide. I have a in the numerator and a in the denominator. So I can divide a to the negative 4th divided by a to the negative 4th. Well, negative 4 minus negative 4 ends up becoming a to the 0 power, which just cancels out because it's 1. B to the negative 2nd divided by b means that the trick would be negative 2 minus 1, because that's a 1, is b to the negative 3rd. So I have 8 to the negative 2 over 5. The b to the negative 3rd is on the top because after you divide, you assume that's just going to be your answer is the numerator. But because after you divided, you got a negative exponent, it's going to drop to the denominator. So in the denominator, we're going to have 5, and then the b to the 3rd. And also, this a to the negative 2nd is also going to go flip down as a to the 2nd. So you have 8 to the 2nd times 5 times b to the 3rd. There's nothing in the numerator, so I'm going to put a 1 there. We can simplify this because you have 8 to the 2nd power 64. And 64 times 5 is going to be 32. So you end up with 1 over 320 b to the 3rd. Here you have a monomial times a polynomial. In this case, it's a trinomial, so we're going to distribute. But actually, before I do that, I didn't even notice when making this problem, you have two things that you could actually combine. 4x squared plus 6x squared, you can add those. That's 10x squared minus 2. So you actually only really have a binomial. Now I'm going to distribute, and you're going to multiply this times this, which is 30x to the 4th y, minus, because negative 2, 3 times 2 is 6x squared y. And you cannot combine these things, so that expression is your final answer. Last one, subtraction problem. Two binomials you're subtracting, but remember you have to think of this as a negative 1, and you're going to distribute it inside. So you actually end up with a positive 9. Bring down everything else. And now we're just going to combine like terms. Remember, you can add only things that have the same exact, well, we could call them a label, but the same exact variables. So while there's an x squared here and an x squared here, this isn't really just 4x squared. This is 4x squared a. So you cannot combine these, but you can combine the negative 4, positive 9. So I'm left with 3x squared minus 4x squared a. Negative 4 plus 9 ends up becoming positive 5. I hope that helps.